Good morning, students, and welcome back to my digital classroom once again. I hope that you all are quite well and doing your regular work. From today, I'm going to start revision, chapter-wise revision. So, first chapter I have taken today, rational numbers. Okay, this will be very important for those students who were remain absent or could not follow my class properly. So, please listen carefully and clear your doubt from today's explanation. After giving explanation, if you have still some doubt in your mind, please ask me freely over WhatsApp number. I will be available to you till 10 o'clock at night. Okay. Now let's see how I have designed this chapter. Rational number. What is rational number? Before starting rational number, I like to say something about our number system. In our previous classes, like 6, 7, you have already come to know about the natural numbers. That means number which start from 1, 2 and infinity. That is natural number. And whole number which start from 0, 1, 2, 3 and infinity. These are whole numbers. Integers are what? The numbers like -1, -2 and infinity and +1, +2 and infinity along with 0 are integers, or we can say all counting numbers and their negative along with 0 are collectively called integers. And fractional numbers is what? Number which is not whole. It is a part of whole number. Now we will study about rational number. What is rational number? A number which can be represented by P by Q form, where P will be any integers. Okay, like that means negative, positive or 0. And Q will be non-zero integer, that means either positive or negative, is called a rational number. Example like 7 by 5, 8 by -3, -1 by 5, -2 by -7, 8, -6, 0, 0 by 4, 0 by -3, 12 by 5, -4 by -1 by -4, etc. You notice here 8, -6 and 0. These are integers. So when we need to represent the rational form, 1 will be the denominator of this. That's why I've written 1 is the denominator of every rational number. So when integer we need to represent a rational number, we have to write down 1 as a denominator. Now then, what is the difference between the rational number and fractional number? It is a very important question. Okay, you see in rational number it is P by Q form. So fractional number also P by Q form. But what is the difference between? In rational number, denominator and numerator may be negative or positive, but in fractional number, neither denominator nor numerator will be negative. It will be counting number, natural number, and moreover, minimum denominator should be 2 and more than 2. Okay, 1 cannot be the denominator of a fractional number. You remember it. 1 cannot be represented as a fractional number. Okay, this is the main difference between rational number and fractional number. Now see the video clip. We come to know about rational number. The idea of the rational number P by Q form. P will be any integer, Q also integer but non-zero integer. Like example, these are the example of rational numbers. rational number, when we need to represent natural number as a rational number, whole number as a rational number, integer as rational number. So how can I write down? By writing denominator as example 7, 7 by 1, minus 11, minus 11 by 1, 0, 0 by 1, the set of rational number. Okay, so I think you have clear. Now next is properties of the rational number. Certain property we have to remember in your mind. While calculation we need to apply those property only. What is closure property? When sum of the two rational number, okay, when we add any two rational number, the result will be a rational number only. Like you see, p by q and r by s are the two rational number. After adding, I am getting m by n. So definitely m by n is also a rational number. Or simply we can say sum of the any two rational numbers will also be a rational number. Clear? So now next property is the commutative property. Say p by q and r by s are the two rational numbers such that p by q plus r by s should be equal to r by s plus p by q. That means in case of addition and multiplication, if we change the position of the rational number, so result will remain same. But it is not true for subtraction and division. So there is no commutative property of subtraction and division. It is applicable only for addition and multiplication. Associative property. What is associative property? Suppose three rational numbers I have taken as example, p by q, r by s, t by u. So if I add in any direction, first of all second and third, then first, or first and second, then third, or first and third, then second, in every case the answer will remain same. That means if we add three rational number or if we multiply three rational number in any mode of arrangement, the result will remain same. It is true for multiplication and addition, but not true for subtraction and division. Mind it. Now additive identity. What is additive identity? Suppose when 0 is added to any rational number, 0 is added to any rational number, the answer is rational number itself. That's why 0 is called the additive identity. Okay, this additive identity like p by q plus 0 is equal to p by q. Clear? So now additive inverse. Additive inverse is what? Same rational number, only the sign change. Okay, say p by q is a rational number. What will be the additive inverse? Minus p by q. And if we take minus p by q, what is the additive inverse? P by q. Why? Because if we add the two rational number, that is rational number and its additive inverse, result will be 0. So when after adding two rational number we getting 0, so one number is called the additive inverse of other number. Okay. So multiplicative identity. What is multiplicative identity? When any rational number is multiplied by 1, like you say additive identity, when any number added with 0, here any rational number when multiplied by 1, result is rational number itself. So this property is called multiplicative identity. Next property is multiplicative inverse. What is multiplicative inverse? Say p by q is a rational number. Its multiplicative inverse will be q by p. Or if minus p by q is there, what will be the multiplicative inverse? Minus q by p. Why? Because p by q and q by p, when you multiply, the result is 1. So when two rational number after multiplying we are getting 1 as a result, the first number is the multiplicative inverse of second number and second number is the multiplicative inverse of first number, vice versa. Say example 6 by 7 into 7 by 6, after multiplying we are getting 1. Minus 3 by 4 into minus 4 by 3, after multiplication we are getting 1. So this is the multiplicative inverse. Distributive property. What is distributive property? So suppose three rational number p by q, r by s and t by u are such that p by q you have to multiply by the sum of the r by s and t by u. So this can be splitted. How? P by q into r by s plus p by q into t by u. So this distribution of the rational number is called distributive property. So when plus sign is there, we say distributive property of multiplication over addition. When minus sign is there in between the two rational number, then we say distributive property of multiplication over subtraction. One important note I'm just written here: while adding, subtracting, multiplying, dividing, increasing order, decreasing order, what about the any type of work related to rational number? Okay, one thing we have to note that the denominator should not be negative. Okay, if denominator is negative, make it positive first. How? By multiplying -1 both the numerator and denominator. After that, you start your normal work. Clear? You have to remember in your mind. So before multiplying, adding, subtracting, we have to note whether the denominator is negative or positive. Okay, if negative, make it positive, then start your normal one. Now, some example I'm just explaining here. All the questions are from your textbook only. It will be very good to you. If you have not done or you have done also, you check your answer with me. So here you see the rational number, set of rational number like 2 by 5 multiplied by 3 by 7 minus 1 by 14 minus 3 by 7 multiplied by 3 by 5. What sequence you have observed? What is the common number here? So 3 by 7 is a common number. So it is minus 3 by 7 or it may minus. So I can write down what? So minus this 1 by 14 is not required, not linked with anyone. So I have written at the end. And since the first number is minus 7 by 3 by 7, so this number should be minus 3 by 7. How I have written? Minus 3 by 7 here I have written here, and outside the bracket I have given plus sign. So that plus minus come back to minus 3 by 7. Okay. After that, what is common here? Minus 3 by 7 is common in both numbers. So I have taken common minus 3 by 7. After that, you are writing 2 by 5 plus 3 by 5. So it is the distributive property of multiplication. Actually it was. Now I am combining together. Then after last number 1 by 14. You will perform the LCM. It is coming 2 plus 3. That is 5 by 5. 5 by 5 is 1. So when same number is multiplied by 1, the multiplicative identity, the number itself minus 3 by 7 minus 1 by 14. Perform LCM. 14 will be LCM. So when we divide 14 by 7, 2 into 3 minus 6 and minus 1 multiply 1, that is minus 1. So after adding I am getting minus 7 by 14. After cancelling I am getting minus 1 by 2. Okay, those who have done it, follow the work. You have to apply at least one identity here, and if you apply identity, your calculation will be simpler one. If someone is not following rules, so it is a product, you can multiply it here. This is also in product, multiply here. Thereafter you will be facing lot of problem, and even when it is mentioned simplify using property, you have to apply the property, otherwise you will not get any marks. Clear? Now here few applications. Additive inverse, 2 by 7 minus 3 by 7 minus 4 by minus 9 2 by minus 9. So what is the additive inverse of 2 by 7? What I said, additive inverse are those number which when added the result comes to 0. So 2 by 7 and minus 2 by 7, if I add together, result will come 0. Okay, the additive inverse of minus 3 by 7 is the 3 by 7. That means just sign change. If it is a negative, make it positive. If it is a positive, make it negative. Then only after adding the result will be 0. Okay, minus 4 by minus 9. First of all, we have to make it positive since denominator is negative. Okay, multiply by minus 1, it will be 4 by 9. After that, 4 by 9, what is the additive inverse of the 4 by 9? Minus 4 by 9. Okay, after simplifying, I am getting 4 by 9 and its additive inverse will be minus 4 by 9. So this number we have to first simplify, then we find out the additive inverse. Okay, additive inverse of minus 2 by 9, same. You have to make it positive here, multiply by minus 1, it will be minus 2 by 9. Now minus 2 by 9, what is the additive inverse? 2 by 9. Clear? Now come to the next property, multiplicative inverse. What is multiplicative inverse? Just reciprocal. We have to reciprocate the numerator and denominator, but sign will be with the always numerator. So what is the multiplicative inverse of minus 16 by 9? It is minus 9 by 16. 12. What is the multiplicative inverse of minus 12? That minus 12 can be written minus 12 by 1, rational form, and then reciprocal minus 1 by 12. Okay, and when this group of number is given, first of all you have to simplify, make it 1. Okay, you cut it, you will get minus 1 into minus 2, there is 2 by 7. So result of this 2 after calculation I am getting 2 by 7. What is the multiplicative inverse? Just reverse it, 7 by 2. Clear? So these questions are from your textbook only. Verify negative of a negative rational number is positive. When x refers to 3 by 7, how will show that negative of a negative rational number is positive? Okay, so now how will start? Given x is equal to 3 by 7. Okay, what is the additive inverse of 3 by 7? So if it is minus sign, will be equal to minus 3 by 7. That means these are equal, but minus 3 by 7 is the additive inverse of 3 by 7. Okay, since 3 by 7 and minus 3 by 7 after adding we are getting 0. So minus 3 by 7 actually it is the additive inverse of 3 by 7. Okay, so now if I find out the negative of the minus 3 by 7, it will be positive. That's why we can say negative of a negative rational number is positive. Okay, so you can perform some activity also. It is given in your textbook. We'll do it. Multiply by the reciprocal of this. First of all, you have to find out the reciprocal. Reciprocal and a multiple inverse is same. Just reverse the position of the numerator denominator, but sign will always with numerator. So minus 4 by 9, its reciprocal will be minus 9 by 4. After that, you have to multiply by 7 by 12. Okay, 7 by 12. 7 by 12 into minus 9 by 4, and we are getting minus 21 by 16. Okay, clear? Now represent the rational number on the number line. 2 by 5, 4 by minus 4 by 7, minus 8 by 5, 9 by 7. So 2 positive, 2 negative I have taken. How will you represent? First of all, you have to draw a line, mark a position of 0. Okay, since this number is positive, it will be on your right hand side. So before how many part this denominator tell you the whole number, you have to divide into 5 equal part. So don't write first whole number. First you take small division of 5 equal part and then write down 1. Out of this 5 division, how many division I have to take? 2. So 0 to this position is the position of 2 by 5. Clear? Next is minus 4 by 7. So negative. So 4 by 7, the whole part we divided into, denominator will tell you how many small division will be there. 7 division. So from 0 you take 7 division. 1, 2, 3, 4, 5, 6, 7. Now the whole part is minus 1. So minus 1 is divided into 7 division. Out of this 7 division, how many part you have to take? Minus 4. So 1, 2, 3, 4. So this is the position of minus 4 by 7 on the number line. Clear? Next is 8 by, earlier actually it is minus 8, I have taken positive 8. Okay, no matter, from whole number 1, 0, you have to, what is the denominator? 5. You have to make small 5 division. Okay, then minus 1, positive 1. And another 5 division, then whole number 2. Now we have to take 8 part. How? 1, 2, 3, 4, 5, 6, 7, 8. Okay, 6, 7, 8. 8 part. 5 plus 7, 8. Up to this part, portion it will be the position. Okay, 8 part you have to proceed. Little one more gap will be there. Clear? You don't write down the whole number first and then divide. First you mark small division and take whole number. Now next one is minus 9 by 7. So minus 9 by 7 means what? The whole number, one whole part, you have to divide by 7 equal part, and you take 9 part. It is possible only if you divide the another whole part into 9 part, 7 part. So 1, 2, 3, 4, 5, 6, 7, whole part minus 1. Another 1, 2, 3, 4, 5, 6, 7, another whole part minus 2. So from this, what to do? I have to take 9 part. So all 7 part is there, and 8 and 9. So this is the position of minus 9 by 7 on the number line. Clear? I can make it clear also. Say I am taking one example. Okay. Draw a number line. Okay. Take 0. Now if it is 5 by 3, 5 by 3, so positive. So what to do? The whole part we have to divide into 3, and out of this I have to take 2 part. Okay. Out of this I have to take 2 part. Divide into 1, 2, 3. So it is a whole part 1. Then another 1, 2, 3. It is whole part 2. So out of this, how many part I have to take? 5. Count 1, 2, 3, 4, 5. Clear? So up to this mass, you have to draw. This is the position of 5 by 2 on the number line. Now, if it is example like you see minus 7 by 6, what will do? The whole part minus 1 you have to divide into 6 equal part, and out of this you have to take 7. It will be possible only then if we divide another whole part into 6 division. So now 1, 2, 3, 4, 5, 6. Clear? Then you write down minus 1. Now another whole part 1, 2, 3, 4, 5, 6. So whole part minus 2. Now you take 7 part. From here we will write down what? If 6 part, and this is the 7 part. Here is the position of minus 7 by 6. Clear? Now next property is what? You find 10 rational number between minus 3 by 5 and 1 by 10. This type of question you have done in class 7 also. Okay. Same thing we'll be doing here also. When the denominator of the two number are not same. Okay. When the denominator of the two number are not same, what to do? We have to make it same by performing LCM. What is the LCM of 5 and 10? LCM of 5 and 10 is what? 10. Clear? So now after that we have to make 10 as the denominator of each rational number. So 5 is there, you have to make it 10. Multiply by 2, multiply by 2. When you multiply by 2 to numerator, same thing you have to do denominator also. So it is coming 6 minus 6 by 10. It is coming 1 by, multiply by 1 because already 10 is there, 1 by 10. Is there thereafter we have to count the gap from one numerator to another numerator, whether you have the 10 rational number or not in gap. So minus 6 to 1, how many gaps are there? Minus 5, minus 4, minus 3, minus 2, minus 1, 0. 1 you cannot take, 6 you cannot take. So we don't have enough gap. So what to do? Actual rule is that whatever the number you require, you multiply it by 1 more. But if we multiply by 1 more in this case, the number will be too big. So thereafter we have to select any 10. So what we have done here, you just multiply by 2. This minus 6 by 10 and 1 by 10, you multiply it by 2. So number will get expanded. So it will be minus 12 by 20 and it is 2 by 20. Now minus 12 to positive 2, how many gaps are there? Minus 11, minus 10, minus 9, minus 8, minus 7, minus 6, minus 5, minus 4, minus 3, minus 2. We have got the 10 gap. After that minus 1, 0 and 1 also there. But we don't require it. Okay. Any 10 members we have to write down between these. So these are the number lies between 10 numbers lie between minus 3 by 5 and minus 1 by 10. Clear? Another example. Find 10 rational number between minus 7 and minus 4. You see These are integer. I have to first represent them in a rational form. You can write down minus 7 by 1, minus 1 by 4. Both are having the same denominator. In this case, how many you require? 10. Okay. Then we have to multiply it by 1 more. Clear? So 7 by 1 multiplied by 11, or 11 by 11, that is 77 by 11. Minus 1 by 4 multiplied by 11 by 11, that is my 44 by 11. Now minus 77 to minus 44, so many gap is there. You write down any 10 members between minus 77 and 44. That means it may be minus 76, minus 75, 74, 73, 72, 71, 70, 69, 68, 10. Any 10 member. Or we can start from minus 45, minus 46, minus 47, so on and so on. Okay. Any way we can proceed. Clear? Now these are the some tasks I am giving you for homework. Clear? You can do it easily at home if you have followed my class. So let me do one thing. I forgot to show you how to represent the number on the number line. I have a video also to prove it how to represent the rational number on the number line. You just check it. Whatever the activity I have done, same thing she will be doing it.
One of the categories of plotting the rational numbers on the number line
properly,
is when the numerators are less than the denominators.
Actually on your notebook.
Let's try to plot 1
They are
by
taking
2
two examples
and
where
minus 1
numerator
by
is
2
less
on
than
the number
denominator.
line.
And some
First,
two examples
we see
and
how
two
we can
examples
plot
for
1 by
when
2.
numerator is greater than
The
denominator.
numerator 1
Follow it
is less than the denominator 2. When the numerator is less than the denominator, the positive rational number will be between 0 and 1. So we draw the number line like this. The number 1 by 2 has to lie somewhere between 0 and 1. Now we divide the length between 0 and 1 into equal parts. How many equal parts is the question? The denominator tells us the number of equal parts. The denominator is 2, so we divide it into 2 equal parts. This line divides this region into 2 equal parts. But what does the numerator tell us? It tells us the number of parts starting from 0. The numerator is 1, and therefore we take one part from 0 and mark 1 by 2 here. We can use the same procedure to mark minus 1 by 2 on the left side of 0. Divide it into 2 parts and mark minus 1 by 2, one part away from 0. Just as integers had corresponding values, rational numbers too have corresponding values. In our example, minus 1 by 2 corresponds to 1 by 2. Let us look at another example where the numerator is less than the denominator. We have to plot 3 by 4 and minus 3 by 4. Let us plot 3 by 4 first. Since the numerator is less than the denominator, we know that the number will be between 0 and 1. So we draw the number line like this, with just 0 and 1 plotted. Remember, the denominator tells us the number of equal parts. Since the denominator is 4, we divide the length between 0 and 1 into 4 equal parts. Drawing these 3 lines gives us 4 equal parts. Now we move to the numerator. The numerator tells us the number of parts from the number 0. Since the numerator is 3, we move 3 equal parts from 0. 1, 2 and 3. So we mark 3 by 4 here. Now let us plot minus 3 by 4. Since 3 is less than 4 and the rational number is negative, we know that it will come between 0 and minus 1. We divide this length into 4 equal parts as the denominator is 4. And we mark minus 3 by 4 3 parts away from 0. That's it. We have plotted the points. But let me ask you a question. You have plotted the numbers 3 by 4 and minus 3 by 4. But do you know which numbers are plotted on these points? Here's your answer. Since this is one part, we mark 1 by 4 here.
This small division
Since these are
no
2
need to
parts,
mention.
we mark
Because
2 by 4
otherwise
here.
it will be very untidy.
Similarly,
Okay?
we can
You have
plot
to remember
minus 1 by
these small
4
divisions are
and
there.
minus 2 by 4 here. This was just for your understanding, and you don't need to mark all the points if you're asked to mark just 3 by 4 and minus 3 by 4. In this video, we will try to plot rational numbers whose numerators are greater than their
Examples,
denominators.
when Numerator
Let
is
us
greater
plot
than
7
denominator.
by 4
How
and minus 7 by
the
4.
activity can be done?
We try to plot 7 by 4 first. The first step in such kind of problems where the numerator is greater than the denominator is to convert it into a mixed fraction form. You would have learned this in your earlier classes, but let me quickly show you how. We only have to divide 7 by 4. We get the quotient as 1 and the remainder as 3. So we write the mixed fraction as quotient, remainder by divisor. This is the whole part and this is the fractional part. So we can write 7 by 4 as 1, 3 by 4. 1 is called the whole number part and 3 by 4 is called the proper fraction part. Each of the three numbers,
We'll be taking
1, 3
at a
and
time.
4,
And
tell us
fractional
something
part,
about
there is
where
per
7 by
fraction.
4 is
We have to
plotted on the
count
number
how many
line.
small divisions are there.
The whole number part tells us the position of 7 by 4. So 1 tells us that the rational number 7 by 4 is between itself and the next whole number. The next whole number is 2. So we know that 7 by 4 is between 1 and 2. So we draw the number line accordingly with just 0, 1 and 2 marked. The denominator of the proper fraction part tells us the number of equal parts this segment is divided into. Since it is 4, we divide this segment into 4 parts. This segment between 1 and 2 is divided into 4 equal parts. The numerator of the proper fraction tells us the number of parts from the first whole number. So it is 3 parts away from 1. So we mark 7 by 4 here. What about minus 7 by 4? We can write minus 7 by 4 as minus 1, 3 by 4. Now the number minus 1 tells us that minus 7 by 4 is between itself and the next number. Make note of the fact that the next number will be on the left hand side since minus 7 by 4 is a negative rational number. So the next number is minus 2. Now we can say that minus 7 by 4 is between minus 1 and minus 2.
That means in
The
between
denominator tells us the number of
here's
equal
minus
parts
1 to
this
minus
length is
2,
divided into.
7 by 4 lies.
So we divide it
Okay.
into 4 equal parts by marking 3
The
lines.
whole part minus 1 together
The
we
number
take
3
and
tells us the
subdivision
number of
3.
parts
Out
from
of
the
this,
number
we have
minus
to take
1.
how many
So
parts?
leaving 3
Three
parts from minus 1, we mark minus 7 by 4 here.
minus 4 by 7.
With that, we
Yeah.
are done with the topic of plotting positive and negative rational numbers. Please practice.
I think it has clear your idea. So this is all about today's class. The next class will be on Saturday. On that day, I'll be revising linear equation in one variable. Okay. Till then, bye bye students and take care of your health.